Looking at section 5.2, part 2, starting with an example, finding exact values. Suppose that the sine of alpha is equal to 4/5 for a quadrant 2 angle alpha, and sine of beta is equal to 1/2 for a quadrant 1 angle beta. We're going to use this information for 4 different parts. So the first thing it wants us to do is to find the exact value of cosine of alpha. So before we can find the cosine of alpha, we need to take the information of sine of alpha of 4/5 and find the missing piece in our triangle. So the drawing that they gave us down below, it shows us that if we have a sine of alpha is 4/5, we're going to have sine, our opposite over our hypotenuse, is going to have a y value of 4 and a radius of 5. That means we need to find out what the x value is. And I think you guys are all pretty smart enough to know that that x value, because you'd have to use your Pythagorean theorem, that is a 3, 4, 5 triangle. And since our x value is going off to the left, so we're over here at this point, that means that x is going to have to equal a -3. If you didn't know it was a 3, 4, 5 triangle, you go through the Pythagorean theorem. So our x squared would have been our unknown, added with our y squared of 4 is going to equal a 5 squared. So you'd have x squared plus 16 is equal to 25. If you subtract that 16 over, you'd have 9. And when you take the square root, technically x is equal to the positive or negative version of 3. And that's when you'd have to pay attention to the fact that we are in quadrant 2. And quadrant 2 means that the x value would have to be a negative. So if we're finding our cosine of alpha, we have our x value divided by our radius. We have an x value of -3 divided by our radius of 5. So we used our sine information. The next piece is going to ask us to find the cosine of beta, find the exact value of cosine of beta. So again, we're going to take our sine of beta is equal to 1/2. That means we have our y value of 1 divided by our radius of 2. Now that one might not be quite so obvious as to what x is, so go through your Pythagorean theorem. We'd have an x squared plus a 1 squared is equal to the radius of 2 squared. So we'd have x squared plus 1 is equal to 4, which means x squared is equal to 3. And if we take the square root, we're left with x is equal to positive or negative root 3. Now in that case, since we are in quadrant 1, it has to be just a positive root 3 for our x value. So this is going to be a root 3. So our cosine of beta is equal to our x value divided by our radius. So we're going to end up with a root 3 divided by 2. So using this information, it wants us to find the exact value of the cosine of alpha plus beta. So they already gave us the information about the sine of alpha and the sine of beta. They already told us that the sine of alpha was 4/5 and the sine of beta was 1/2. And we went through the process of finding our cosine of alpha, which we found was a -3/5. And our cosine of beta, which we found as a root 3/2. And they want us to go through and find the cosine of alpha plus beta. And so we are using a sum or difference formula. In this case, we're using a sum formula. So our cosine of alpha plus beta is broken down into the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. So our cosine of alpha is going to give us our -3/5 multiplied with the cosine of beta, which is our root 3/2. We're going to subtract the sine of alpha, which is 4/5, times the sine of beta, which is 1/2. So doing a little bit of fraction work, not really so basic fractions, but we have some fractions. So if I were to look at my denominators, I have 5 and 2. So in both cases, we're going to have a denominator of 10. So if I have a -3/5 multiplied by a root 3/2, that's going to give us a -3 root 3. If I have my 4/5 times the 1/2, we're going to be left with just a 4/10. Yes, I know that simplifies, but I don't want to simplify it because I need to subtract my fractions, which I'm going to leave my common denominator of 10. And I'm just going to have a -3 root 3, take away 4, and that's going to be my final answer. Not so pretty, but that's what it is. On the next piece, they want us to then go and find the sine of alpha plus beta. So again, we're going to go through the same process, looking at our sum formula. So again, the same type of information that's filled in here. The first 2 pieces are what were given to us. The second 2 pieces were what we have found. And then we just have to use them. So our sine of alpha plus beta is broken down into our sine of alpha cosine beta plus cosine of alpha sine of beta. And we fill it in. So our sine of alpha, which is our 4/5, is going to multiply with our cosine of beta, which is root 3/2. We're going to add with that our cosine of alpha, which is our -3/5. That's going to multiply with our sine of beta, which is 1/2. And again, these kind of turn into denominators of 10, which will leave us 10, so we can add them together. So if I have a 4/5 times a √3/2, we have a 4√3. And if we have a -3/5 times a 1/2, we end up with a -3/10. And throw them all together in one big fraction. You have that 4 square root of 3 added with a negative, so we're going to call that a -3. And that whole thing is over top of 10. Now, the last piece of these notes talks about the sum and difference formulas for tangents. So the tangent of alpha plus beta is going to be broken down into the tangent of alpha plus the tangent of beta on the top, divided by the 1 minus tangent of alpha, tangent of beta. So it just says in words, the tangent of the sum of two angles equals the tangent of the first angle plus the tangent of the second angle divided by 1 minus their product. So it starts with a plus, and we have a plus on the top, and then it goes to the opposite sign on the bottom. The next one has the tangent of alpha minus beta, and that's just your tangent of alpha minus tangent of beta divided by 1 plus the tangent of alpha tangent of beta. And again, the words, the tangent of the difference of two angles equals the tangent of the first angle minus the tangent of the second angle divided by 1 plus their products. And again, whatever it's given in the parentheses is what's going to start off on the top, and then you have the opposite on the bottom. These are on your formula sheet, so it's not something you have to memorize. You just need to know how to use. So let's try one. If we were to verify the identity, the tangent of the tangent of x plus pi is equal to tan x. So if we take the harder looking side, the tangent of x plus pi, we're going to break that down. So just like they gave us up here, we have an addition, so we're going to set up our addition. We're going to have the tangent of alpha plus the tangent of beta. That means that we're going to have the tangent of x added with the tangent of pi divided by 1 minus, we have a 1 minus, and then we're going to multiply tangent alpha, tangent beta. So we're going to have tangent of x, tangent of pi. And now if we start simplifying some things down, if I have tangent of x, I can't simplify, but tangent of pi, what do we know about the tangent of pi? Well, that would be our sine over cosine, so we would have a 0 over -1, which means that we'd end up with, that's going to be 0. And if tangent of pi is equal to 0, anything times 0 is going to be 0. So what are we left with? We're left with a tangent of x divided by 1, which is just our tangent of x, which is what we were trying to get in the end.